Hello everyone, welcome to Mapping the Invisible. Divakar will be giving us a presentation today and I'm going to hand it on over to you. So take it away.
Thank you. Hello everyone and welcome to my session. Today I will be talking about mapping the invisible. So in the session I want to explore like how ancient science of archaeology, like what happens when it meets with modern technologies like Neo4j, LiDAR and LLMs that could help us in rediscovering some of the lost knowledge and as well make sense of unseen connections which we missed to connect long back. So we will see a lot more details into what I'm trying to convey here. But before that, I just want to introduce about myself. I'm Divakar, currently working as a technical architect at Pliosoft. And if you would like to connect with me or if you have any questions regarding the session, feel free to reach out to me on this LinkedIn handle. I would be more than happy to help you. So before getting into the actual agenda, I just want to clarify like what is the problem space that we are trying to address here. And I didn't intentionally step into this archaeology space, nor it was part of my official work. So it was part of the OpenAI hackathon that was conducted like 3 to 4 months before. So where a group of developers, AI engineers, data scientists, and even archaeologists themselves came together and we worked on a single fascinating goal. So that is to reveal the hidden civilization. And when I want to talk about the LiDAR, I just want to give you a few examples like what it does. So now let's take a look at this image. So this is a dense forest in the Guatemala region. And if you look closely, you could see there is a stone structure peeking through the trees. But to the human eye, this is just an endless stretch of dense forest, right? And it is almost impossible for you to imagine that there could be something significant lying beneath these canopies. And that is what people thought for centuries until LiDAR came along. So what LiDAR helps us to reveal is the entire physical structure beneath these canopies. Like you could see the pyramids over here, the roads, infrastructures, and even houses. Every details beneath the layer of the nature has been visible over the LiDAR. And that is when I realized archaeology is not alone, like not only for meant for digging through the dirt, like it is mapping the invisible, and that is why the title of the talk, Mapping the Invisible. So by this time, like you might be wondering, like, are we even at the right conference? Yes, we are. Like how LiDAR was able to uncover the physical structure beneath the layers of the nature. What we are trying to do is like what we are going to work with is the knowledge graph that is going to uncover some of the hidden insights beneath the layer of the data. And specifically what we are going to focus on today is the post excavation process that will be conducted by the archaeologists. Like so once they are done with the excavation, like what they will be doing is like they will be preparing some field reports about that particular site, like what are the features that they found, the methodologies that they used, about the survey details, like which region and what is the medieval period of those identified artifacts. So all those details are captured in the form of field reports. And right now, these field reports are scattered across geologies and even across different institutions. So that is what we are trying to solve today. We are trying to build a knowledge graph out of those scattered field reports and trying to get some insights from it. And this is going to be our agenda for the next 25 minutes or 30 minutes. So we have already seen what is the high level overview of what we are going to try to solve today. We have already seen like what is the problem space that we are going to address, and we will progress through we will understand like what is RAG and why specifically we want to implement via the graph RAG, why we want to go with the knowledge graph, and then we will move on to the ingestion process. So this would be the key topic of today's session, where we will be discussing detailed steps and the process that involves in creating this ingestion pipeline of creating both lexical graph and domain graph, we will see like what are those, and then we will construct those knowledge graph, and in the final we will see a demo of it, like how it works and also the code part of it. So let's start with RAG. And specifically with the RAG, right? So there is a lot of misconceptions and multiple interpretations going on around in the space because that is understandable, right? So this is a fast moving space and everyone trying to publish their own narratives. And but at the end of the day, like what happens is like we have 10 different definitions for something that is actually quite simple. So that is how RAG can be interpreted now. So what does RAG mean then? So RAG means like you need to retrieve the information from any data source for that matters, augment that information to the LLM context, and generate the response. So this is the crux of the RAG. So it doesn't care about what kind of database that you use. It doesn't care about whether you use vector database or any other database for that matter, or it doesn't matter like what type of pattern that you use behind the scenes. All it concerns is about like you need to retrieve some information, provide it to the LLM, and generate the final response, because these LLMs are trained on the old data, and if you want to share some new data or some relevant information that is private to your own organization, you might need to go into this approach. And there are different flavors to implement this RAG. One of the most straightforward way would be like the naive way of implementing RAG is to use any database and do a keyword search, a normal keyword search, like how we usually do with the relational database, and then retrieve the information and then augment that into the LLM context and then provide the final output. So this would be the most naive way of implementing RAG. But this also works for most of the use cases. And additionally, what you could do is like you could bind some of the chat histories along with whatever the information that you retrieve from the database. That could provide additional context to the LLM to respond in the better way. So this is one way that you could extend your naive way of solving the RAG. And one of the most efficient way to implement the RAG is using the vector database. The reason why it is the most efficient way is that you have this data and you don't store the data as such into the vector database. You store the semantics of the data to the database that you use, which is mostly a vector database. You will be converting that data into an embedding format that holds the semantics of the data. And when you are trying to do a query or when you are trying to retrieve the information, what you do is like you do similarity search on top of whatever the query that you get. You convert that as well into the embedding and then search across your database to retrieve relevant information back to the user, back to the LLM. So by this way, you could build a most efficient RAG pipeline within your system. And there are different variations to implement the vector RAG. Like you could also combine that vector RAG with an evaluator agent. You can ground that result, and there are multiple modular RAG versions. So there are different versions in implementing the vector RAG. But however hard you try to implement this vector RAG implementation, you could only succeed retrieving the data and the information from the database. So what about knowledge, insights, and wisdoms? So you won't be able to capture these with the normal implementation of the vector RAG. So for that, you need to rely on the knowledge graph, the graph RAG methodology. I like to call this as wisdom graph. So when you call this as a wisdom graph, like what are the different data types or document structures that you need to address? Look, that should be the first point that you need to address. So you can broadly classify your data into two categories. One is the unstructured data, the other one is the structured data. And there is also a semi-structured data, which we don't care about in this particular session. So within this unstructured data and the structured data, there are two types of graphs that you could create. So one, with the unstructured data, you could go about creating a lexical graph, and with the structured data, you could go about creating the domain graph. But there is also one more variation to this. You could also create domain graph based out of an unstructured data, which we will see in detail, like how we can go about it. But in general, this is how you will be able to create a lexical graph and the domain graph. But to understand the first question, like what is a domain graph and the lexical graph, I just want to compare it with an analogy. So if you consider a domain graph to be your world, to be the domain that you work on, lexical graph is something that you how you interpret that world or how you talk about that world. So that is what lexical graph is more concerned with, and domain graph is actual domain that you are going to work with. And once you are done with creation of these two graphs, lexical graph and domain graph, your job is not done yet. You need to create a bridge, a link between these lexical graph and as well the domain graph, to gather some of the insights from the underlying data that you have. So that is what we are going to see today. And so first of all, we can see like what are the different steps that is involved in the ingestion pipeline for creating a lexical graph. So when it comes to creating a lexical graph, again, you need to consider what are the different file formats that you need to address within that unstructured document or structured document that you want to work with, right? And specifically, if you are addressing a lexical graph, then it is going to be an unstructured document that you need to address. So there could be different types of file formats that you need to address. And the ultimate idea or the end goal of your architecture design is to be to extract the contents, text content from these different documents, different file structures. And it is not only specific to these file extensions. It could also be an image. It could also be a video format. It could also be an audio format. So your responsibility is now to implement a custom extractor within your framework to extract the contents from all these different documents and have it as an in-memory object or something, like you store it, those text documents. So, but the problem with this approach is you need to now research on different supported libraries. So there are n different libraries that is supporting to extract the text content, image content from a PDF document. And similarly, there could be multiple other libraries that could help you with these type of extractions from different file structures, from the PPTs, from the document docs. So there are different supported libraries that you need to research on. And once you are done with that, your job is not done. You need to maintain that custom code. And also you need to worry about like how you are going to deploy this, because there could be some cases like where you need to rely on certain Windows dependencies. Like in those cases, like you need to think about like where you need to deploy, like whether you need to deploy it as a Windows container or Linux container. So there are different other constraints that you need to worry about. And also these documents doesn't end with the text. So inside these documents, you might be having an image, you might be having table content, you might be having formulas. So you need to verbalize those things so that you provide those additional context to those LLMs. So instead of worrying about all these different factors, what you could do is like you can rely on some existing OCRs. There are different OCR solutions out there that will help you to extract the contents, images, tables, formulas, etc., from different file formats that you have. And I was specifically using Azure Document Intelligence Service for this purpose. And within this Azure Document Intelligence Service, I was using layout model, which is an out-of-box model that allows you to capture different sections within your field reports. Like because since I am handling with the archaeology field report, each field report will be having different sections, and each sections will be having different figures, different tables. So I need to capture all those things. And this was a perfect fit for that particular use case. And this could be a perfect fit for most of the use cases that you are handling, because there are multiple different formats that the service is supporting. And you can learn more about this into the by going into the Microsoft documentation. But the crux of this document intelligence is like you get to hold of these different sections, figures, and tables. And you might be happy at this point because now you solved a lot of different challenges that you had in the first place. Like if you want to implement this in custom implementation, that would be a headache for you to maintain. But now it is somewhat okay for you to maintain, but still there are few other problems that you need to address. Like it is not only just getting the image content, getting the table content. You need to now think from a perspective like how it can be made understandable to an LLM, because at the end of the day, like the LLM is gonna address these things and gonna get you an insights from these different contents, right? So for that specific purpose, what you need to do is like you need to have a separate pipeline to verbalize these image by passing it to an LLM and then convert it into a textual format and then store it in an embedding format into a vector database. That could be one of the way that you could go about. And with the table format, what you could go about is like you can convert those table formats like the rows, cells, and data into a markdown representation that is more understandable by the LLM and then feed it into the LLM. And also this formulas, you need to contextualize that and then feed it into the LLM. So these are the different methodologies that you could follow if you want to build a meaningful unit for your different sections that you might be having. And now we move on to the third step in this ingestion pipeline, which is to determine the chunking strategy, because now you need to work with an embedding model, because we talked about the vector RAG, right? So the vector RAG will be mostly predominantly dependent on the embedding models rather than the chat completion models, which have a larger context window, but embedding models do have a context window limit. So you need to be careful on how you are chunking your sections. And I could broadly categorize these into 3 chunking strategies. So the first chunking strategy would be the fixer chunking, and it doesn't matter like you are going with overlap or without overlap. So it is easier for you to implement this strategy because it is just a threshold or a limit that you have for you to break down a long document into chunks of a document. And that is easier to implement. But the problem with this approach is your context might be missed or scattered across different sections. And there is efficient way of doing a chunking strategy, which is known as semantic chunking. So this is like if you want to split your documents based on sections, paragraphs, pages, to an extent, you will be able to preserve the context. The only problem with this approach is that you will be having have variable chunk size based on the page size or the section size that you decided to split. So you always need to be careful on this so that it is not exceeding the context window of the embedding model. And the final chunking strategy that you could follow is the LLM based chunking. Just handing it over to the LLM and asking the LLM to chunk those big documents into small chunks. This seems to be a good approach, but the problem with this approach is it is expensive. If you have a system that is handling of for handling this much of complexity, then you can go about with this LLM based chunking. And if you ask about like if there is any magic formula to implement this, like there is no such magic formula for when it comes to chunking strategy. Even with semantic chunking, you could address most of the use cases, but that doesn't mean that fixer chunking is not used anywhere. Like in case of question and answer agent, right? So you could always go with the fixer chunking, which could work a lot better than the semantic chunking. So that is one of the use case and one of the examples. So there is no definitive formula for implementing this chunking strategy. And specifically what I followed within this archaeology space is going with the semantic chunking. Especially I splitted the documents based on the sections. And this is the visual representation of what we have covered till now. So you have an unstructured document and you use any OCR for that matters. In my solution, I used Azure Document Intelligence Service to get sections, figures, and tables. And your job is not done yet. Once you gather these information, you need to contextualize those figures and tables and even formulas if you have any within your document, and then store it in some kind of in memory, which you might be using in your further process. The next step would be to enrich those content that you got from your chunking strategy. So within this enrichment phase, what you need to do is like you need to again iterate through each of those sections, and you need to see if there is any references to a figure or a table that might be residing in, like say suppose like you are handling section number 10, and inside that section number 10 you might be having a reference to figure 2 which is explained in the section number 2. You need to have those details as well in the current section, so that you develop this meaningful chunk. Otherwise your chunk will be without a meaning. So in order to do that, like you need to have all those references in place, and whatever the contextualization that you did in the previous step, based on the figures and the tables, now you can map them to whatever the reference that you get here. You can append those verbalized content, you can append those table markdown representation, you can append those formula representation back to those individual chunks, and then create the semantic chunk. That is how you could create this semantic chunk. It is not a direct process. Once you go with the chunking strategy, you will be able to create this semantic chunk. You need to do this enrichment phase to ensure that each of those chunks is holding certain context and it is preserving that. So now we are almost done with the ingestion phase, ingestion pipeline. The final step would be for you to get this into an embedding format and then place it into a vector database. So now we are using Neo4j for that. So within Neo4j, there is a capability for you to store this embedding format as well and create a vector index on top of it. And once you are done that, you could see something like this, the node and edges created within your knowledge graph. If you consider each documents that you are going to pass as a document node, that will be containing the file name and what are the number of the pages that you might be having for that particular field report. And each of those sections can be considered as the semantic sections that we created in the previous steps. And each of those sections will be containing the property called embedding and also the page number, because at the end of the day, like if in case like you are working with a conversational flow, what you might also need to worry about is like how to provide the user with a citation. In those cases, like you need to have this page number so that like you can directly reference to that particular page in that particular PDF. And you could also additionally create another edge between those sections if you find two sections to be similar and talking about the same context. You could go about creating a similarity relationship with the help of Neo4j cipher query, and then create those additional edges. And also you could also create an edge for if in case like each of those section is having a reference to individual images, so that now you can directly bind these image URLs into the chat conversation that you might be having. And this is the end of creating a lexical graph. So now we will see how to build the domain graph. Considering the lexical graph, domain graph is somewhat simpler. If in case you are working with a structured document and you already know about the ontology scheme, it is more straightforward. You can create those nodes and entities and relationships within your knowledge graph. But the problem is like once you want to handle this domain graph as part of the unstructured document, like you need to rely on the LLM to come up with an ontology scheme, or you might be having something in your mind as an ontology scheme which you can feed into LLM to give you back with certain nodes and relationships within the documents that you're handling. So once you are done that, like it is the normal process, you need to construct the graph based on whatever the response that you get from the LLM. So at the end of this process, you might be capturing something like this. In my case, it is a field report. Each field report is going to have a case attached to a site, which will be conducted by a certain institution that will be authored by a person. and each survey will be having certain methodologies. That could be a different variation to these methodologies, and those methodologies will be able to deduct certain features, artifacts. So this is the domain schema I have for this particular archaeology space. And whatever we have done till now is similar to what is depicted in this image. It is like a broken bridge. You have this lexical graph and you have this domain graph, but there is no link between these two graphs. So if you want to create this link, like it is on the whole a different topic that would require an additional session around that alone. But I can give you certain tips and tricks for you to create this link. So how I created these links within this archaeology spaces, like I chose a certain entity because I was working with the same unstructured document for both lexical graph and as well the domain graph. But this might not be the same case for your scenario, because you might be having a different structured data for you to create a domain graph and unstructured data for you to create a lexical graph. So in those cases, you need to ensure whatever the entities that you might be interested on should be more or less unique across different graphs that you might be creating. Or once you created that, like you need to do a fuzzy similarity search between the different entities that you might be having, so that like you resolve this entity deduplication and then try to link different graphs, like the lexical graph and the domain graph, with these methodologies. So these are some tips and tricks that you could follow if in case like you are just working with the unstructured document, and you can go about creating the same entity name across different graphs and then create a link while you are doing the final implementation. So once you are done with the lexical graph and domain graph, you can create those relationships additionally. So by doing this, like you can build a retrieval pipeline. So whatever we have seen in this session is just about the ingestion pipeline of the lexical graph and the domain graph, like how you need to create those lexical graph and domain graph. But the next of you to implement this or to see the result is to create a retrieval pipeline where you could make use of this vector search in the first place, and then do a multi-hop traversal to the successive domain graph that you might be having, so that you can provide additional context to your LLM that could help you to retrieve more insights. And by this, we are done with our session, and I will just share you like how it sees in the live environment. Let me get back. So this is the live environment of this archaeology experiment that I was doing. So here you can see like there are a number of potential sites that we discovered with this methodologies, and specifically with knowledge graph. If you want to research, like you can go to this chat window and then you can see existing chat histories. Like I've already asked like what is this field report is about, like what are the different methodologies that is used, and you will be able to retrieve a lot of information from these field reports. And if, in general, like if you want to research more on to this archaeology space, like you can go to this and see like what it looks like in the real life environment. Like you can visually see like what is the artifact that is lying beneath these canopies. And that's it. Thanks for this opportunity. Let me get back to the slides. Yeah. So if you have any queries and if you would like to connect with me, you can reach out to me on the LinkedIn. If you want to provide the feedback, you can scan this QR code. If you want to get into this repository, I will try to add the knowledge graphs as well into this existing repository that I have. But for now, you can see like what is the architecture design that I use to implement this entire Archaeos implementation. Yeah.